This week we're going to study the physics of baking. Baking has arisen already on several occasions in this course. During the first week I told you about my favorite recipe, Nestle Toll House chocolate chip cookies, and we discussed the number of molecules there were of the different ingredients. A couple of weeks ago you made what is at least my favorite lab in this course, the molten chocolate cake, which of course involves the physics of baking. But so far we haven't been able to actually go into the physics of baking. That is, how do recipes for baked goods work and produce the delicious outcomes that we all so much enjoy? And the reason for that, the reason that we haven't discussed baking as of yet, is that as you will see this week, the physics of baking involves many, in fact, if not most, of the ideas that we've discussed up until this point. Baking involves elasticity, viscosity, emulsions, heat transfer, solubility, many concepts like that. And this week we're going to go through what is going to be, on one hand, a bit of a review of the concepts that we've discussed up until this point, and on the other hand, we're going to show you how these ideas apply to baking. So before we begin, I just want to give one caveat. We are not professional bakers. We are scientists. And our intent in this week's baking discussion is not to basically go through every method and every technique that is required to basically make a baked good delicious. What we're going to do is to expose the basic scientific issues that underlie baking, and by putting them together in your own mind, they will hopefully help you make sense of recipes. Before we begin, I want to quickly go through and just discuss how baking involves many of the physical ideas we've discussed to date. Let's start with elasticity. You'll remember in week 4 of the course, Bill Yassi's made this wonderful strudel dough in which he showed you how stretchy and elastic strudel dough was, and indeed the elastic properties of dough are one of the central features of baking. What gives rise to that elasticity? Well, there are at least 3 different things that give rise to the elasticity of baked goods, if not more. The 3 that I want to emphasize, though, and are probably the most important, are first, the properties of gluten. Pia talked earlier about gluten in molecules and their interactions and how they give rise to the elasticity of strudel dough. Secondly, the elastic network that occurs in eggs. Many baked goods involved eggs, and you all know from simply cooking eggs that you produce a scrambled egg or whatever kind of egg which actually has an elastic modulus, and the same types of networks, of gelation networks that occur in eggs also occur in baked goods, presumably that include eggs. And the third main ingredient of elasticity is that given by starches and sugars, which are present in both flour and also any added sugar. So for starches especially, you might recall from last week's discussion of viscosity that when you pour starch granules into a liquid and you then heat up the liquid, the starch granules expand. And Dave explained to you how when the starch granules expand that they interact with each other, and in principle they get to the point where there are so many starch granules that when you squish on the bread or the whatever the dough is that has the starch granules in it, that also creates an elastic modulus. So when you think about what is giving rise to the elasticity of baked goods, it's really very complicated. It involves the interplay of all 3 of them in whatever configuration happens to be made when you go through your baking protocol. And this is but these are all wonderful illustrations of elasticity. A second major idea that underlies baking is viscosity. You might say, how could it include viscosity? Because after all, when you take a cake out of the oven, you can squish on it and it's got an elastic modulus. You can put a weight on it and measure its elastic modulus. Maybe when you measured the elastic modulus of a food in the elasticity week of the course, you used a baked good. But you see, baked goods also have viscous properties. And the reason for that is that if they didn't, breads wouldn't rise, cakes wouldn't expand, cookies wouldn't expand when you make them in the oven. Anytime something expands and rises, that involves the flowing of molecules by each other. And it's indeed this viscous property of batters that is absolutely critical for their success. A third scientific idea that is important in baking is emulsions. So cakes are emulsions. To see that, what you can do is just cut open a cake and look inside at the structure. And what you see are lots of little bubbles. Those bubbles, of course, are the result of gas expansion that occurs during baking. And that is something that we will also talk about. But the fact is that cakes and baked goods tend to be made of bubbles that are packed together. So for this reason, the ideas that we discussed in Emulsions Week are also going to be important. And indeed, you will recall then that we said that when the volume fraction of bubbles reaches some critical amount, then they start to squish into each other and things stop. And that same sort of process occurs during baking. Another scientific idea that is important in baking is heat transfer. You, after all, heated a molten chocolate cake, and by cooking it, you were able to measure the heat diffusion constant of water. For that, our wonderful equation L is equal to the square root of 4 dt came in handy, and that's what we used, indeed, to make the measurement. The heat transfer to baked goods obeys the laws of diffusion, but there's an additional complication, which is that cakes rise, baked goods rise. And when they rise, heat actually is able to move not just by undergoing random walks, but actually moves because of the rising itself. And this can change, depending on the circumstance, the law that governs heat transfer in a baked good, which makes it more complicated than those that we've discussed before. Finally, a last set of scientific ideas that are important in baking involve chemical reactions producing gases, which we discussed early on in this course, and also the general idea of solubility. After all, when you make a cake and you put sugar in it, then there's always water and there's sugar, and the sugar dissolves in the water, and that's actually important for the entire baking process. So the ideas that we've talked about solubility and the dependence of solubility on temperature all come into play. So, as you can see, the physics of baking involves many of the scientific ideas that we've discussed so far in this course, and that is indeed why we haven't been able to delve into it before. So now let's dive in and start to explore how these different physical processes interplay with each other to make delicious baked goods. And to help us with this, we're very fortunate to be able to visit the kitchen of Joanne Cheng of Flour Bakery, who's going to show us how to make yellow birthday cake, how to make pie dough, and how to make bread. And you will see when you watch her go through and describe all of the different things she's thinking about when she makes these products, how these different physical elements come into play.